Okay, Danny, I'm going to try to get you straightened out here. This was a document that showed up in my Google Drive. I don't know how you did this, but I don't understand these answers. It says it's on 8.6 review worksheet, which was for today, Thursday. Okay. Now, you gave me this answer for this problem. But if you look on, well, first off, I had a picture posted with today, and that was picture 1, and it's got an example where you get the base is the same. You change this 27 to 3 cubed, and then you drop down your exponents, which is exactly what you'll do on number 1. Also, you might want to go back to 320 notes. So go find that video, okay? Because down here at the bottom, number 5 and 6, we did 2 problems, just like number 1 and number 2 on today's homework. Okay, so look at the picture number 1 for help on 1 and 2, and go back to the notes from 320. All right. Sorry about the shaky camera. Hope it don't make you sick doing this on my phone. Then this is the answer you had on number 2, and all we need to do is change the 25 to a 5 squared and 125 to a 5 cubed, and then again you would just set your exponents equal. Okay. Then on number 3, starting with number 3, I posted a picture for help on 3 through 6 whenever you're solving logs or solving log equations with logs everywhere. Okay, we have logs everywhere. Now you should also know that when you subtract, you turn it into a division, and when you add, you turn it into a multiplication. Okay, 3 times 10 is 30. That follows our exponent rules. That was from earlier lessons this week. Okay, so you might want to go back and rewatch some videos. Now you have log base 7 equals a log base 7, so now you can just drop those 2 down and make them equal. You can also go back to 320 notes. Okay, again back to 320, and look number 1 right here. It's where we had logs everywhere. We had the same log on both sides. Now it does have to be a single log on this side and a single log on that side. You just drop down those arguments and solve that equation. Okay, so you got me all confused here on what this is. Okay, because again, that's what it tells me you got for the answer to number 3. All right, this is the number 3 I'm seeing. All I would do is drop the 7 down and drop the x down. I get x equals 7. Okay, number 4, both sides here are log base 7s. Then that means this 3x minus 6 has to be equal to that 2x plus 3, and you just solve this. Okay, and then you can do the same down here on number 5. Now you see how you have 2 logs on the right. You can't have that. You got to have a single log. So you got to say, what do I do with this subtraction? I make this a division. Numerator of x, denominator x minus 1, because whenever we divide, we subtract. Okay. Here we have an addition, so we'll make those 2 at multiplication. And now these 2 are equal to each other. All right. Now on the bottom 4, whatever those numbers are there, 7 through 10, again, I had picture number 3. Gives you help on that. When you have equations that are missing logs. Okay, eventually you got to get it down to where we can do the hook. You see on this example, we would take this minus 5, move it to the other side. Where is it at? And get positive 5. We would take this log and move it to the other side and subtract it. And then what do we do when we're subtracting? We make it a division. So you need to go back and look at picture 3. Then you can also go back to the notes from 320. Okay, and look right here. We're working examples where we had missing logs, so we have to do the hook. All right. So I hope this helps. Again, because you've got me all confused about how these are even possible answers. Okay, so maybe, I don't know, maybe it's the wrong worksheet. I'm looking at the wrong worksheet. I don't know. Let me know in an email if this helps. I'm going to send this to your email.